So my curiosity is getting the better of me on this here, guys. So this is my Matsushita compressor, refrigerant compressor, of course, off my Suzuki SX4, and I've replaced it recently, and there's a number of issues with it. The main one being that the pulley bearing here was absolutely bitched, but I suspect it has a shaft seal leak as well. But I'm going to disassemble it, and we'll get a look at it. Okay, so as I said, guys, apart from the bearing being absolutely bitched on the pulley here, the clutch itself is basically got three pins that the pressure plate kind of pivots on. So if you watch closely, all I'm doing is actually applying some voltage to the coil, right? Roughly system voltage, and you'll see the coil is definitely functional. But if you look at it, the plate is actually not pulling in symmetrically. That's because there's extreme wear on one of the three pins there. See how it's not really pulling in symmetrically? Anyway, so of course the point to the clutch is that when it's de-energized, when the coil's de-energized, the pulley can spin unloaded from the compressor, and then as soon as you want AC, I'll just apply voltage here. You can see that, of course, it locks it up, and of course, as the belt rotates the pulley, the crankshaft of the compressor itself would rotate the compression elements, the vane inside the compressor. So let's take this off, get a look. It's just a 10 mil. Don't lose, there's a couple of shims in here, guys. There's a critical gap between the face of the clutch pulley itself and again, we'll call it the pressure plate. There's a critical gap there. The manual specs it out. Don't lose these little shims. So, Jesus. That bearing's gone, huh? So it's retained by a couple of a circlip there. The coil is within here. It's retained by yet another circlip. But I should have pointed out just the basics about the compressor before I started taking it to bits. There's two ports on here, of course. The larger of the two is for the suction, and of course the smaller is the discharge. Facility for the electrical connector. There's an overheat sensor here. I take it this is just probably a bimetallic switch. Is it self-resetting? No idea. I've never had it trip, but if the compressor overheats, it will open the circuit, and of course the coil will open and you'll lose the drive to the compressor, dropping the pressure. Kind of makes sense, right? And in addition to that, as a safety, there is also an overpressure mechanism there. At what pressure that when that blows, that will not be self-resetting. That's for damn sure. The system will lose all its refrigerant. Of course, it's a safety mechanism. I don't think you'd like your evaporator exploding inside the distribution plenum in the cabin, right? So other than that, it's the casing. I take it somewhere within the housing here, there's going to be, I believe it's a vane type. There's a couple of different types of vane type, but we'll see soon enough. I don't see how it could be anything else other than a vane type. It's certainly no piston, and I don't think it's squirrel, so I'm no air conditioning expert, but I think it's a vane. So I've just removed the wee retaining circlip there, guys, but you will need a puller arrangement of sorts to actually pull this off. A pair of safety specs are always good with a circlip and probably your puller. I don't know if I can do this one-handed. This might spin and embarrass myself here. Let's see. No easy to do this stuff one-handed while you're trying to hold the camera, I can tell you. Anyway, there's no on with much force, of course, right? Just pressed onto the bearing. So there you can see this bearing was replaced. What have I done on this compressor over its service life of almost 330? Wow, look at that coil. That coil is starting to clearly overheat. That's no long for this world. I was hoping I could maybe put that in my parts bin, but that looks like garbage now, even though it remains functional. Can you see that? Yeah, that is not normal. The problem with air conditioning systems, of course, is when you lose refrigerant, if it continues to operate, there's a pressure switch cutout, but because of the temperature pressure relationship which exists with refrigerant, right, even so long as there's a fraction of the charge remaining in the system, you're not going to go below the pressure limit. This will continue to operate and it will just cook itself to bits. And you'll compromise the seal. You can see the state of the coil. It won't do the clutch any good either, obviously, right? As the pressure goes up, or as the temperature goes up, everything just starts to cook itself to bits. And this is the first time I've seen in here since I've replaced it. Over the service life of this compressor, what have I done? I've changed the bearing once. It was an aftermarket bearing. Actually, some of the balls are gone, which begs the question, where are they? Oh, there they are. So clearly that is absolute pieces. I guess I got to that not a moment too soon on my vehicle. And yeah, this is garbage now. So I replaced the bearing once, I replaced the coil twice, and as you can see, the clutch is obviously the clutch proper. The mechanical portion of it is shot as well. So I just decided to change the whole compressor. That's why I'm in a position to disassemble this now. So this clutch is actually held in with just a single circlip there as well, guys. I don't know if you can see it. Guess you can maybe see it. There's garbage in there. All the debris. That's another part of the bearing seal. There's the circlip there clearly. So I'll take that out. Should be able to lift out the once the other circlip is off here, guys. This should just pop off, right? You may need to pry it with a screwdriver a wee bit. No doubt the corrosion will get it somewhat stuck on there. Again, this is an aftermarket coil. It's alright, I guess it served its purpose, but that's why the wiring is a wee bit weird here, in case you're wondering, in case you're familiar with the original setup. So there's the nose. I am interested to see if there is any fluorescence on this. Just a second. That's just actually corrosion. That is not fluorescence. That is fluorescence. That's the tracer dye. See how bright it is there? It's unbelievably bright. And it is, of course, in the system, right, when I was trying to find a leak. So this is good and bad. I was actually hoping this was going to be leaking from here. But it looks tight. It's alright. There's 4 bolts. Go through the various casting members there to hold the whole assembly together. See if it comes apart. And it looks like there's another 4 small bolts to hold this casting here to the vane housing proper, I think. We'll see. Another Titanic situation. Okay, so the 4 bolts are extracted there. Just knocked that part with a mallet. Surprisingly, it is coming apart. There's a vane type compressor, as it's suspected. Well, it had to be, basically. But that's not the type of vane I was expecting. That is, there's 2 types of vanes, as I said. I can't remember the name of that. I'll look it up. I'll show it to you in one of the textbooks. Yeah, eccentric vane rotor, guys, is the term that I could not recall. There's 2 types. Through vane, which basically has vanes that actually kind of cross over like this and slip 2 members that kind of slip over or between each other. But clearly the Matsushita there is the eccentric. You can see how it's offset from the center, hence the name, of course, and the 3 vanes in the system. What else is, so here's just a little snippet from the textbook here. You can see basically as the refrigerant comes in, this is rotating in a counterclockwise manner. The volume kind of goes from increasing to a neutral point and then starts to decrease. And of course, when it gets to a really small volume, the pressure would skyrocket, lifting the valve, and then through the transfer port, in the case with our or my compressor, it transfers over to the sump or high pressure side. So yeah, excellent book. If you guys, this is not for the faint-hearted though. This is a serious book, man. It is a great book. Stephen Daly's Automotive Air Conditioning and Climate Control Systems. Really good book. Daly? Sorry, Stephen, no sure. You can see this part of the housing. A couple of seals, some needle bearings on the nose of the crankshaft itself. And you can see, looks like there's a circlip there retaining the the seal. A couple of different points it could leak. I guess you can definitely see the dye in the oil there. You can definitely see these veins, of course, are going to get flung out by centrifugal force. So here I've lifted the rotor out here, guys, right? I've got them veins slung out a wee bit. So there's like very little wear on this. We've got scoring on the face of there. I don't know if that's normal or not. On the housing, amazingly good condition. More needle bearings to support the shaft in the back. And yeah, you can see the porting there. So here's the suction port, of course, right here. And so you can see where it comes in, and again in the rotor just expanding and then contracting. So yeah, a couple of ports here. Oh sure, continue to dig. You know there's always two fasteners that are hiding somewhere in a recess, right? That you don't realize that are there. Even managed to bore my cat. So here's all the components, guys, basically disassembled in a somewhat exploded view, I guess. So we've already covered the clutch components and kind of how they work. So here's the nose casting that the crankshaft actually rides on the front of. There's the crank itself with the rotor. You can see the veins thrown out. So again, needle bearings to support it. There's a seal of sorts here. And there's an O-ring on this casting here, which is the bore that the veins actually impress upon in order to generate the compression. So this is the where the pressure is produced, and then you can see the valve here. As the chamber actually starts to decrease in volume, the pressure increases, of course. It will lift these two valves that are sitting there, and it pushes the pressure into this transfer housing of sorts. So if you can appreciate, guys, that this actually sits in this orientation. So you can see there's a cavity in the casting, and then a transfer port, let's call it, that makes up with this portion. So then the pressure, again, this is the, let's call this the rear bearing casing, right? And there's the, again, needle bearings that support the rotor on the backside, and it transfers the pressure through that port into that port. You can see there it goes all the way through, and then the pressure actually makes its way into this casting here, which is a assume oil sump of sorts. This is where a good portion of the system lubrication would reside, I think. And judging by what I believe is valving on the backside of this, there's a screen there. I believe that's an oil pickup screen. So I think through the various differential pressures that are acting on the system here, and I think these are basically aspirators. I don't know for certain, but there's certainly ports here. And I think, as I said, the pressure coming through here would pick up the oil from the various sumps, and it's aspirated into the refrigerant as it actually flows through the system. I'm no expert, guys. I don't know. I'm just trying to make some sense of this, right? So anyway, I hope that all made some sense. I'm glad I did it. Actually, it took a wee bit of time to disassemble it. Not too bad, surprisingly. It all came apart. All the fasteners like brand new inside, you know, as it should be, of course, right? A compressor is designed to last the life of the vehicle, really, and more often than not, it's the ancillaries that will let you down, right? You know, the drive side of things, namely the clutch or the coil, or maybe you get a leak of sorts. But assuming that the refrigerant is kept at its proper mass, there's the proper weight of refrigerant in the system, there's a correct lubricant in the system remains pristine. That's why you get refrigerators from the 50s. When somebody cracks open the compressor, they look brand new, you know. So anyway, that's it, guys. I hope that made some sense. That's it, boys. Cheers.